So if you actually graph all those 4 lines, then you can visually see they're wanting to know the area trapped under there. So another way to ask the exact same question is to integrate this function dx, because x is the variable, from what to what? What are the x values that I care about?
0 to 8.
Right, from 0 to 8. So to finish the question, we just need to finish, or we need to integrate this by hand. But it's phrased in a different way. You need to know that those are asking the same things. All right, so I could integrate this to get x. I could think of this as x to the 1/3 raised to power by 1, divide by the new power. It's the same as multiplying by the reciprocal. Check by taking the derivative, check by taking the derivative, and I still need to evaluate from 0 to 8. So put that over there to the side to indicate you haven't done that yet. Otherwise, you better not say it's equal to the previous step, because that would be wrong. One time I'm going to plug in 8. The next time I'm going to plug in 0. I don't know. All that's going to go to 0, so I'm not going to make it look like it's plugged in. And then subtract them, and whatever this mess of arithmetic comes out to be is going to be the area bounded between those regions. And much better than we did the first week when we came back. It's not an estimate like left sum, right sum, midpoint sum, trapezoidal sum. It's exact. Because these integrations are defined by that one worksheet we did. It's defined as the limit as n approaches infinity. So you've got infinite number of rectangles that are infinitely thin, of the sum of, to make sure you add them all up, and then length times width. You guys remember doing that worksheet where we just tried to make sense of it? We did it real quick, but that's why this is a way to represent that area. Okay, so all that comes out to be 0. That's easy. This is a little harder to deal with, but I guess you could start off with 8 to the 4th, but that's a really big number. It's probably easier to do the cube root of 8 first. That would be 2, and then raise it to the 4th. 2 times 2 would be 4, 8, 16. 16 divided by 4 would be 4, times it by 3 would be 12, plus 8 should be 20. So I believe the answer should be exactly 20 units squared, because we are talking about an area here. But we've got our calculator, so why not also throw it in there real quick and see if it's consistent with that. You see, I integrated from 0 to 8. My function was 1 plus x to the 1/3 dx. Okay, I had to think about it real hard. It says the answer is 20.00000037. So does that mean something's wrong with ours? No, it's fine. Your calculator has like built-in like programs, algorithms to figure these things out, and sometimes it has a little tiny bit of rounding error. So it's trying to say 20. The calculator is actually not quite smart enough to know it's exactly 20. Okay, so other than kind of the setup, going from these equations to that statement is really the only thing unique about 45. So let's have you try one of those.